In the previous videos, we mentioned that stress response can be quite useful, but there are downsides to experiencing too much stress. But what specifically happens to a person's body when experiencing long-term effects? For the purpose of this lesson, we're going to refer to long-term stress as chronic stressor or chronic stress to indicate that it is not momentary or even in response to a single stimuli. Before we give examples of what happens to the body, we need to first note that the body is well adapted to short-term stress. Just like the general adaptation syndrome shows, we have a resistance phase in which we can successfully function. However, over time, there is wear and tear. It's like wearing a set of shoes that don't quite fit you right. When you first put them on, they are maybe a bit uncomfortable, but you can tolerate them without too much notice. But say you were going to go for a hike or go out dancing. Well, your feet would then be covered in blisters and aches before too long. Rather than healing right when you take off those ill-fitting shoes, you now have to recuperate for a while. When talking about the body, this wear and tear on a system is known as allostatic load. Allostasis is your bodily process of trying to maintain homeostasis or balance. You might recall that balance, along with regulating growth, is the entire purpose of the endocrine system. Your body is constantly releasing hormones to try to manage and fix your bodily systems. But after a while, the costs of constantly maintaining this homeostasis begin to add up. There are backups in processing these chemicals, or specific organs and glands run out of the energy or nutrients necessary for conducting necessary processes. Thus, this chronic exposure to stress results in physiological overload. Once the stressor goes away, we are free to recuperate, but that process also takes time. So, what are these negative effects? For one, patterns and quality of sleep begin to suffer when we're stressed, with reports of both insomnia and greater lethargy depending on the individual and situation. This is due to cortisol being released into the system at irregular periods, thus inhibiting proper circadian rhythms. People also begin to suffer from chronic fatigue as their body attempts to recover from lost sleep. Chronic stress also affects cardiovascular response, with long-term increases in blood pressure levels and heart rate that place undue strain on the heart. The stress response is designed to help increase blood flow so we can fight or flight, but the constant strain on these blood vessels and the overexertion of the heart can cause tears and lead to disorders such as atherosclerosis and heart failure. We also see changes in weight and eating habits, including both increases and decreases depending on the individual. For instance, about half of those watching this video likely report binge eating when they are stressed, whereas the other half report feeling anything but hungry. The stress eating is due to the body requiring sugars for the cortisol to quickly convert to energy, hence why most eating is for food high in sugar content. Most people don't stress eat salads. The lack of appetite, on the other hand, is due to the adrenaline in the system inhibiting the digestion system. Yeah, it feels weird that your body both demands more energy but also shuts down the process for getting that energy, but that be how the body do. As mentioned, neural pathways start to break down as well, and new neurons fail to grow at the same rate. This can result in less access to past memories and even failure to store new memories. Your neurons are cells just like any others in your body, and they die and need replacing. However, when experiencing chronic stress, the resources aren't available to replenish those dead neurons and repair connections. The following video highlights these effects and more regarding how stress influences brain functioning.
Are you sleeping restlessly, feeling irritable or moody, forgetting little things, and feeling overwhelmed and isolated? Don't worry, we've all been there. You're probably just stressed out. Stress isn't always a bad thing. It can be handy for a burst of extra energy and focus, like when you're playing a competitive sport or have to speak in public. But when it's continuous, the kind most of us face day in and day out, it actually begins to change your brain. Chronic stress, like being overworked or having arguments at home, can affect brain size, its structure, and how it functions, right down to the level of your genes. Stress begins with something called the hypothalamus-pituitary-adrenal axis, a series of interactions between endocrine glands in the brain and on the kidney, which controls your body's reaction to stress. When your brain detects a stressful situation, your HPA axis is instantly activated and releases a hormone called cortisol, which primes your body for instant action. But high levels of cortisol over long periods of time wreak havoc on your brain. For example, chronic stress increases the activity level and number of neural connections in the amygdala, your brain's fear center. And as levels of cortisol rise, electric signals in your hippocampus, the part of the brain associated with learning, memories, and stress control, deteriorate. The hippocampus also inhibits the activity of the HPA axis, so when it weakens, so does your ability to control your stress. That's not all though. Cortisol can literally cause your brain to shrink in size. Too much of it results in the loss of synaptic connections between neurons and the shrinking of your prefrontal cortex, the part of your brain that regulates behaviors like concentration, decision-making, judgment, and social interaction. It also leads to fewer new brain cells being made in the hippocampus. This means chronic stress might make it harder for you to learn and remember things, and also set the stage for more serious mental problems like depression and eventually Alzheimer's disease. The effects of stress may filter right down to your brain's DNA. An experiment showed that the amount of nurturing a mother rat provides its newborn baby plays a part in determining how that baby responds to stress later in life. The pups of nurturing moms turned out less sensitive to stress because their brains developed more cortisol receptors, which stick to cortisol and dampen the stress response. The pups of negligent moms had the opposite outcome, and so became more sensitive to stress throughout life. These are considered epigenetic changes, meaning that they affect which genes are expressed without directly changing the genetic code. And these changes can be reversed if the moms are swapped. But there's a surprising result. The epigenetic changes caused by one single mother rat were passed down to many generations of rats after her. In other words, the results of these actions were inheritable. It's not all bad news though. There are many ways to reverse what cortisol does to your stressed brain. The most powerful weapons are exercise and meditation, which involves breathing deeply and being aware and focused on your surroundings. Both of these activities decrease your stress and increase the size of the hippocampus, thereby improving your memory. So don't feel defeated by the pressures of daily life. Get in control of your stress before it takes control of you.
You may also notice that you are more prone to sickness when you are stressed. For instance, rate of student illness increased during finals week. One study of monkeys found when researchers injected monkeys with the flu virus, monkeys that were put in cages, a very stressful experience for many animals, they were more likely to come down with the flu than monkeys who were allowed to roam free. Now remember, in this study, both sets of monkeys were injected with the flu. Studies of humans show similar results, with stressed athletes taking longer to heal from injuries, and stressed people are more likely to develop colds, and there's evidence even for lowered vaccine effectiveness depending on people's stress levels. This is because cortisol shuts down the immune system and ability to fight off foreign bacteria and viruses. I guess the evolutionary rationale here is that healing and protecting your body requires a lot of energy. However, you don't need to heal and protect if you're dead. Therefore, all energy is diverted to fighting and flighting, not so much at healing and repairing. A fun fact, this is also one of the theories for why ulcers are related to stress. The H. pylori bacterium is adept at spreading when the immune system begins to falter. Stress can also change how your brain even processes emotions and memories. With all of these effects, it is no wonder that many researchers spend their careers trying to understand stress and how it influences human psychology, neural functioning, and immune responses. In the next video, we will introduce a few of the methodologies used by these stress researchers.